So in order to solve this question, we know that we have been given the details of diffraction grating as well and the Slit separation experiment as well. So we know that the formula for Slit separation is lambda equals to ax over d. We have to find x, right? So make x a subject because x is your fringe separation. So d lambda over a is equals to x. Now we have d. D is our distance from slit to screen, which is here 1 meter. So it would be your one. So your x would be x equals to lambda over a, right? Now, so we either we don't have lambda and we don't have a as well. So it is written that a slit separation is 500 times greater than line spacing. So can I say a is equals to sorry d is equals to 500 a? Yes, I can say why because it is saying the slit separation is 500 times greater than the line spacing of grating. Yes or no? So I would be just replacing. Sorry, I have written it differently, oppositely. It should be A equals to 500 D. Why? Because slit separation is greater. Slit separation is 500 times greater. So 500 would multiply by D. So now instead of 500, instead of A, I would be writing 500 D. Now we have formula for diffraction grating and lambda equals to D sine theta. D would be n lambda over sine theta. So your n is your number of order and the yellow light is of first order. Your n would be 1, n is equal to 1, d is equals to lambda over sine 30, angle is already 30 given to us. So it would be pi lambda over 500 multiplied by lambda over sine 30. So lambda cuts, your final answer is x equals to 1 over 500 over sine 30, which is equal to 1 into exponent minus 3. So answer would be part C. I hope it is clear. Sorry, I just started. Now read MCQ 50.
Why can an observable interference pattern never be obtained between two monochromatic beams of light from different lamps?
Okay, now read MCQ one by one.
The frequency of the light from the two lamps can never be the same.
So that's not possible. The frequency can be same. The frequency depends on the time period and we can make it same, right? So the frequency can be same. It's not possible that two lamps will never have the same frequency. So that's not possible. Now read MCQ part. So A is wrong here, right? A is wrong.
The light from the two lamps can never be coherent.
Yeah, so for coherence, what is the main point? Constant.
It's a constant phase difference.
Yes, so for that, yeah, it is possible that when you're using two different lamps, so it is possible that the light is emerging from a point but at different times. So that's why they may be of different phase difference. The phase difference would not be constant. So that's why we do one thing, we use one light source but use double slits like this. So when the light pass from this, they already diffract, and then again when they pass through this, so they diffract more. So in order to use just one lamp so that the light could be coherent. So this is right here because we need a light to be coherent of constant phase difference. So if we use two different lights, it is not possible for constant phase difference. Okay.
Yes, sir.
And the part C is saying the temperature of the filament of two lamp. We don't need temperature in it. Temperature is independent. The wavelength of a light from a two lamp must always be different. No, because we said that light should be coherent. So if a coherent means same wavelength. So for different, it's not possible, right?
Yes.
So that should be his answer. Now tell me the answer of 53.
C.
C. Why not D?
Because the frequency remains.
Because no, I'm saying why not D? D for delta. Last one.
Because if you increase the width of the gap, then the diffraction will be lesser, so it won't really.
Yeah, I remember I told you one point that for a better diffraction or a good approximation of diffraction, we need the wavelength and the slit separation should be same. Yes or no? This
Yeah.
wavelength should be equal to this slit separation, which is now not equal. The slit separation is too big and the wavelength is too small. So that's why if we increase the wavelength, so in order to make it close to the slit separation, so the diffraction would be greater. So our main point is slit separation should be equal to wavelength for better diffraction.
Okay.
Okay. Okay. Now read 54.
Light of wavelength lambda is emitted from two-point sources R and S and falls onto a distant screen. At point P on the screen, the light intensity is zero. What could explain the zero intensity at P?
Zero intensity at P. So if the intensity is zero, we need it should be
Dark.
I will say yes, dark spot or a district. So part A is saying light from two sources emitted 180 out of phase and a path difference should to P is 1 over 2 lambda. Yeah, this thing is right. Initially, the half statement is right. The path difference is of 1 over 2 lambda. It is right because in destructive interference, we take
Yeah.
in decimal. So this is right. But out of phase is not possible. Already told you that the wave should be in phase for interference, right?
Yes.
So that's what it is making wrong. And part B is saying lambda is not possible because it is for constructive interference. Path difference cannot be lambda. If it is lambda, it is constructive interference, right?
Yeah.
So part B and C are wrong in this way. Let's read part D. Light from two sources is emitted in phase, yeah, right. And the path difference is half lambda. That's right too. So D is our answer. Okay, clear? We need a destructive interference for intensity to be zero, and we know in destructive interference, path difference is 1 over 2 or 3 over 2, like this. Okay,
It
and
always
so
has
on.
to be
It always have to be,
a decimal or a fraction.
yeah, yeah, yeah. Because whole number is for constructive interference. So let's keep the class still here. In the next class, we will start in stationary wave. I have already sent you this file, superposition. So revise the notes and attempt the past paper of it. Okay?
Okay.
Okay, so thank you.
Thank you, sir.